Hello, my name is Nicholas White, and I'm an applied automation and design engineering major. And this is my senior presentation on my internship with GH Metal Solutions. The first project is titled Material Handling Automation. This project's goal was to automate the delivery of palleted material to one section of the plant to another, to make it as lean as possible. The first step of this is to research AGVs, or automated guided vehicle producing companies, to get quotes for pricing and demos on site. The second step is to measure both facilities and produce an updated plant layout to give to the AGV producing company. The third step is to study forklift paths that are carrying the palleted material. Then I must update the plant layouts, and after getting the quotes and demo later in the year, GH Metal Solutions will get funding from the parent company and implement the AGVs. The four companies I have been able to connect to so far is Cross Robotics, SSI Schaefer, MIR Robotics, and Omron Robotics. This facility, named Airport Facility, is located on Airport Road. I started here in my measuring process for the plant layout. The plant layout took around about a month and a half to complete. And when I started here, I measured the entire facility, going to welding and robot welding, 2 presses and 2 bed lasers in this department, then 2 maintenance and 2 lasers. Then I did the entirety of this section, which all of those big numbers are bed lasers. Then I moved over to this rightmost section, which the top part is our paint line, and the bottom part from the greenish area down is our shipping. On this slide, in this large image of the plant layout, is where I started measuring the airport facility. Mainly here, specifically. I used the lines from the concrete where the foundation was laid from the support beams that are located there. And those lines gave me a good grid point to where I could use to place them accurately on the plant layout. The concrete lines go horizontally across all of those lines and horizontally. Now the east facility is located just east of the facility. So we call it the east facility. This facility is much longer and much emptier than the airport road facility. This is mainly used as a shipping out facility, and it mainly is used for storage and prep to leave. The future plans of this facility is to expand into the more empty areas, to put more robots in, put more robot welders, and to put more racks to hold more material. When I first walked into the facility, I immediately saw the wide open space and thought that there is really nothing here. But looking closer, I saw that there's pallets of material on them everywhere, mainly in these purple areas you see on screen. Everywhere else was just empty spaces. They also do not utilize racks. If they did utilize the racks, they would be able to utilize all the space quite a bit more. The future plans, like I said in the previous slide, is to make this facility as lean as possible. This facility will house the demo for the AGVs, and it will mainly start in this area and be contained in this area that is on screen. Now this is the second part of the project, which is forklift studies. This is the airport facility with forklift lanes added. This took some time to study because I had to go to each individual section and make sure there was enough room for the forklifts to pass, and so that way there would be enough room for the forklifts to pass each other. This facility was very crowded in its forklift paths, and it did have a complete circle starting and going around the mezzanine area and completing all the way around through paint line and through each individual section, which is good for the AGVs. This is the plant layout with the forklift studies attached in the east facility. The east facility was most important because this is where the demos would take place. The demos will mainly focus in right here because of the receiving, shipping, and other robotics in the way. I studied these paths inside the facility, and I had to study where the forklifts frequented most and where they could all fit. The hard part of making this was making where all the staging and storing was, because there's more staging and storing in the red areas in the middle of the box. Sometimes they're empty, sometimes they're filled to capacity. It is very difficult to pinpoint exactly where it is at until it is taped down so the AGVs could make their rounds. The demo for the AGVs will start here in receiving. Then it will head to bed lasers, which that section circled. And from bed lasers, it will go to 3 different places. Either press brakes, robot welding, or hand welding. From each one of those, it may go to a different part of the facility, but you'll most likely go to shipping. On its way there, it will be staged, wrapped up, and then staged on that area right there for it to be put on forklifts to be put onto trucks. After that, it's shipped off to either Airport Road to get the rest of the shipment, or go straight off to where it's shipping to. The second project is the cobot claw design. The first step was to create prototypes in SolidWorks. The second step was to present the prototypes to my manager, Eric Chambers. After that is to integrate them into the robot arms and projects, so we would save the most money. A few designs of the grip for the grippers for the cobot arm is this. The image on the right is the main tube I used for holding the motor of the claw. On the left is a completed design, which I have 3D printed. I'm still waiting on approval to get the motor to attach it to the cobot arm we have purchased, which I'll be discussing a little bit later. This design is for more stronger grip application. It allows the robot to have more firm grasp on it. And this is just a first phase. I presented this one to Eric, and he said I need to re-evaluate the gear patterns, which is understandably when going back and looking at it. The third project is the robot arm implementation, or the cobot. The first step is to construct a table strong enough to hold the arm. And after the arm is built, I need to bolt the arm to the table. And then the third step is learn about and program the arm. The table. The task of the table is to hold the cobot arm. It is to construct some sheet metal and metal tubes that was excess from other projects around the facility. It was cut using a bed laser. The sheet metal was, and the metal tubes I hand cut and hand welded onto the sheet metals. And the yellow sensor there is a safety curtain sensor. I am still waiting on safety relays to implement that as we speak. The cobot arm, as pictured here, is an Omron based arm. It has six points of movement, and it operates in the flow system while being programmed. This robot is different from being programmed than ones I've experienced. The silver node that sticks out from the black suction cup area is the camera and also the handle. There are 3 buttons there from top to bottom. Is grip, claw, and move. While holding the move button, the robot is able to be positioned in any way by hand, not needing any external controllers. The claw mechanic is so the operator may press it and it opens or closes relative to where it's positioned at the current moment. The top button is the vision button. That is that way if a vision job is needed to identify a part or to landmark something to start a project, you press that and you click the correct program when you get back to the controller. Setting up the robot's controller was very difficult. It didn't come with any applications or any sort of programs on it. When I first set up the robot and plugged it all in, it had to download all of it from the robot, which is very odd. And then when I tried to activate the gripper gave me errors. When I looked further into it and made contact with the Omron and the company who sold it to us, they said I must connect the USB that came with it to the internet, download all the gripper files, then upload it to the controller. This was not a very streamlined process. It was very difficult downloading it all. But when it was all downloaded, the robot works perfectly. And it was very, very strong robot. If you have any questions, please feel free to email me at nwhite3@stu.jsu.edu, or you can reach me at my telephone number is 256-996-0855. Thank you for your time. Have a wonderful day.